discussing about data warehousing concepts. As part of data warehousing concepts, we know what is dimension columns, what is fact columns, and what is dimension table, what is fact table. Now we'll go and discuss about types of schemas. In the data warehousing, there is a concept called types of schemas. We'll go and discuss types of schemas now. So totally there are three types of schemas. Let me explain what are those. Let me open Power BI Desktop. So let me bring some tables into the Power Pivot. How can we bring the tables is click on Get Data. I want to bring the tables from SQL Server. Click on SQL Server. I'll provide the server name and database name here. Let me copy the server name. And database name is optional here. Click on OK. So I'll bring the tables this time from AdventureWorks Data Warehouse. From this database, I'll bring the tables. When I expand, I can go and choose the tables. I'll bring customers table. I'll bring customers table. I'll bring products table. And I'll bring sales table, fact internet sales. Fact internet sales. Three tables I'm bringing. One is fact internet sales. Second one is product. Third one is customers table. Click on load. So in interview, you will get few important questions here, guys. They will ask you what is star schema. They'll ask you what is snowflake schema. And they'll ask you which schema will give better performance. So which schema will give better performance? Which schema will give better performance? So star schema will give better performance or snowflake schema? Which schema? Which schema will give better performance? Either star or snowflake schema. Either star or snowflake. And when we will go with star schema, when we will go with snowflake schema, when we will go with star schema, when we will go with snowflake schema. When we will go with snowflake schema. So 99% of the time will get either star schema or snowflake schema. Very rarely you will get galaxy schema. We'll discuss. Very rarely you will get galaxy schema. So they will ask you some more questions. In your project, which schema you used? In your project, what is the schema you build? What is the schema you build? So in your project, in your schema, how many dimension tables and fact tables are there? In your schema, how many dimension tables and fact tables are there? How many dimension tables and fact tables are there? Perfect, guys. Like this, you'll get a lot of questions from the data modeling end, guys. So if you can understand this class, you can answer, guys. You can answer all of them. You can answer all of them. Let me explain first. So I bought some three tables. So first let me explain what is schema. First let me explain what is schema. First I'll go and discuss what is schema. First I'll go and explain what is schema. So what is schema is collection of tables and their relationships, we call it a schema, guys. Collection of tables and relationships, we call it a schema. I can write like this. Collection of tables and the relationships. This is nothing but schema, guys. So there are three tables and there are relationship between the tables. We call all this together, we call it what? Schema. So when you load the tables, we'll establish the relationships. That means establishing the relationships means what? Doing the data modeling. So once after loading the tables, when you do the data modeling, the output of data modeling will result in the schema. What is data modeling, guys? Establishing the relationship between the tables, we call it as data modeling. Once you load the tables into the Power Pivot, once you establish the relationship, once you're done with the data modeling, the output of the data modeling will give you one schema. The output of the data modeling will give you the schema. The output of data modeling will give you the schema. Yes. What schema it is? Okay, it is schema. Totally, we have three types of schemas here: star schema, snowflake schema, galaxy schema. So this will comes under which schema? This will comes under which schema? Let's understand now. So you have what? A one dimension table and multiple. So in this schema, I have multiple dimension tables. Dim means dimension table. Customer table is a dimension table. Product table is a dimension table. And sales table is a fact table. In this schema, I have dimension tables and fact tables. So whether it is star schema or snowflake schema, first let me explain what is star schema. Let me explain what is star schema. In a schema, if every dimension table is directly linking with the fact table, we call it as star schema, guys. Let me write here. In a schema, if every dimension table is directly linking with fact table, we call as what? Star schema, guys. We call as star schema. So in a schema, I said that this completely we call it a schema. In any schema, in a schema, if every dimension table is directly linking with the fact table, we call it a star schema. Look at this. This is the fact table, and these are the dimension tables. Are they directly linking with the fact table or not? Yes, they are directly linking with the fact table. They are directly linking with the fact table. In a schema, if every dimension table is directly linking with the fact table like this, we call that kind of schema as star schema. So now I have two dimension tables, they are directly linking with the fact table. We call this as star schema, guys. Yes, we call this as star schema. Right. So then what is snowflake schema? So star schema, okay, we understand that in any schema, if one dimension table is directly linking with the all fact tables, we call it a star schema. Let me show you here. Look at this here. There is a fact table here. Sales is a fact table, and customers is a dimension table. Products is a dimension table. Time is a dimension table, and store is a dimension table. This complete we call it a schema. In this schema, every dimension table is directly linking with fact table. This kind of schemas we call it as what schemas? Star schemas. This type of schemas we call it as star schemas, guys. Now here also it is star schema. So then what is snowflake schema? So what is snowflake schema is, in a schema, if minimum one dimension table in a schema, if minimum dimension table, if it is not directly linking with the fact table, minimum one dimension table, if it is not linking in a schema, if minimum one dimension table is not linking with the fact table directly, is not linking with fact table directly, we call as snowflake schema, guys. So let me show you. In a schema, if minimum one dimension table is not linking with the fact table directly, look at this here. I'll bring some more tables. There are product subcategory and product category tables. I'll bring that product subcategory and product tables also. Click on get data, not Power BI dataset. Click on get data. I need to bring it from SQL Server, and let me provide the server name here. Let me provide the server name, and let me press OK. I'll go to AdventureWorks data warehouse again. This time I'll bring product category and product subcategory. Product category and product subcategory. Click on load. I'll bring product category and product subcategory. Click on load. Go here. Now if you look at this here, so let me explain. Now tell me, guys. So in this schema, product category is a dimension table. Product subcategory is a dimension table. Product category is a dimension table. So this is also a dimension table. So few dimension tables are directly linking with the fact table. Customers table is directly linking with the fact table. Products table is directly linking with the fact table. When you consider these three tables, we call it a star schema. Star schema. But when you look at this here, this table is not directly linking with the fact table. It is linking through another dimension table. Product subcategory is linking to product table and then to the fact table. Product category is not directly linking with the fact table. It is linking through another dimension tables. When any dimension table is not directly linking with the fact table, minimum one, we call it a snowflake schema, guys. When you consider all these four tables, when you consider these four tables, it is what schema? Snowflake schema. Snowflake schema. When you consider all these tables, which schema it is? Again, it's a snowflake schema. Snowflake schema. So only with these three tables, it is star schema. With these four tables also, it is snowflake schema. With these five tables also, it is snowflake schema. Why? So there, few of the dimension tables, they are not directly linking with the fact table. They are linking through another dimension table. Keep in mind clearly, in a schema, if minimum one dimension table is not linking with the fact table, directly, we call as snowflake schema, guys. We call it as what? Snowflake schema. So look at this. So in this, whether it is a star schema or snowflake schema, sales table is a fact table. Customers table is a dimension table. Sales representative table is a dimension table. Time table is a dimension table. Product table is a dimension table. So when you consider this five tables, it is star schema. When you consider this five tables, it is star schema, guys. So when you consider brand table and category table, it is snowflake schema. Brand table is also a dimension table which is not linking directly to the fact table. It is linking through the product table. Category table is also a dimension table which is not directly linking to the fact table. It is linking through another dimension table. This kind of schemas, we call it as snowflake schemas, guys. Important. Again and again, I'm telling, in interview point of view. Every interview, they are asking this question. Fine. Okay. We understand which one is star schema, which one is snowflake schema. So I said that they will ask another question, which schema will give better performance? Whether star schema will give better performance or snowflake schema will give better performance. Let me explain, guys. So my client is asking to create one report. Create one report. So this is what schema? Snowflake schema. Using this snowflake schema, my client is asking to create one report. In the report, client is asking to show me product category. In the report, client is asking to show me product category. Show me product subcategory. Show me product name. And show me sales amount. Show me sales amount. I want to show product category, product subcategory, product name, sales. Product category, I can take it from product category table. Product subcategory, I can take it from product subcategory table. Product name, I can take it from product table. Product name, I can take it from product table. And sales amount, I can take from sales table. In the snowflake schema, whatever the visual client is asking, if I want to create that visual, I want to create the visual on 4 tables. 4 tables. Fine. Okay, good. For now, keep it aside. How can you convert this snowflake schema to star schema? Someone tell me. I want to convert this to star schema. Someone tell me how to convert it.
Remove the
remove. I want all the data. I don't want to simply remove that.
Establish relation between fact and the dimension table.
You will not have a common column.
Merging the 2 tables. We will create one custom.
So if people are telling that, so directly establish a relationship between these two. If I have a common column between this and this, I'll directly establish it. As I don't have a common column here, I'm giving the relationship using another table. So that is not right answer again. Yes. So removing the tables is also right option. Merge the 2 tables. Perfect. The answer is yes. What you need to do is you need to combine these 3 tables into one table. You need to combine this 3 tables into one table. When you combine these 3 tables into one table, that one table directly I can link with the fact table. Then my schema will come to star schema. How can you combine these 3 tables into one table? In the Power Query, you have a concept called merge queries. In the Power Query, you have a concept called what? Merge queries. Using merge queries, you can join the tables into one table. Join these 3 tables into one table, and so this one table itself will contain product category information, product subcategory information, product name information. So when you merge these 3 tables into one table, now when my client is asking to show product category, I'll take it from same one table. When they're asking to show product subcategory, same table. When they're asking to show product name, same table. When they're asking to show sales, same table. Now we understand that whatever the client output is asking, when it is snowflake schema, when you want to create a report, it is you are creating the report on 4 tables. In the star schema, we'll create the report on how many tables, guys? We'll create the report on only 2 tables. Now tell me which schema will give better performance. When you create a visual on 4 tables, will it give the better performance, or 2 tables it will give the better performance?
Yes.
There is no doubt 2 tables. When you create a visual on 4 tables, every time when you open this visual, it will join the 4 tables internally. It will give the data. Let's assume to join the 4 tables to give the data in the output, let's assume it is taking 60 seconds of time. I have huge volumes of data here. It is taking 60 seconds of time. When you combine these 3 tables into one table, when you link this one table, when you create a visual on only 2 tables, So when the client open this will join only two tables. To join only two tables, it will give the data within 20 seconds of time. There is no doubt. Here 60 seconds when you join four tables. When you want to join two tables, it is only 20 seconds of time. So obviously star schema will give better performance. Okay. So if interviewer is asking, so which schema will give better performance? The answer will be star schema, guys. Why? In star schema, we'll have less number of tables. We'll create the visuals on less number of tables in star schema. If it is snowflake schema, we'll have more number of tables. And we want to create the visuals on more number of tables. Fine, guys. The next one is, so in your project, which schema you build? They'll ask you. So you load the tables into PowerPoint and you build the schema. They might ask you in your project which schema you build. So in your project, which schema you build, whether it is a star schema or snowflake schema. So you can tell anything, guys. Sometimes when you load the tables, when you establish the relationship, you might get snowflake schema. So when you load the tables, when you establish the relationship, sometimes you will get star schema. Star schema. Either answer is correct, but answer them. You build a star schema. You tell them you build a star schema. So either one you will get it. Either a snowflake schema will get, star schema will get. You tell them star schema. Why? Because it will give better performance, right? Tell them a star schema. Okay. Now the question is, so when we are going to get star schema is going to give better performance, then what is the need of building snowflake schema? It is true, right? Interviewer will ask a question. Yes, you are telling that star schema will give better performance. Then why we need to go and build snowflake schema? What is the need of it? You can always go and build a star schema, right? Why you need to build a snowflake schema? Sometimes we know how we will even convert a snowflake schema to star schema. You have a concept called merge queries here. Using the merge queries, we can do that, right? When you are able to know how to combine the multiple tables into one table, like products table, category table, subcategory table into one table, then why you need to go and separately build snowflake schema? The answer is, so when we'll go with snowflake schema is, so star schema will occupy more space. The problem with star schema is, star schema will occupy more space in the Power Pivot model, in the Power Pivot model. So the disadvantage with star schema is, star schema will give better performance. There is no doubt. Star schema will contains denormalized data. I'll explain what is the denormalized data. So as star schema contains denormalized data, as star schema contains denormalized data, as star schema contains denormalized data, star schema will occupy more space in the Power Pivot. More space in the Power Pivot. Yes, I'll tell you why. But when it comes to snowflake schema, it contains, snowflake schema will contains not denormalized data, it will contains semi-normalized data. So it will not even contains normalized data, it will contain semi-normalized data. A snowflake schema contains you'll understand, guys. So then snowflake schemas will occupy less space. Snowflake schema will occupy less space when compared to star schema, guys. So snowflake schema will occupy less space when compared to star schema. So there are sometimes, so if you have enough space in the power pivot, so in the power pivot I have a lot of space, the best way is go and build the star schema. So I said that star schema will occupy more space. When I have enough space in the power pivot, building the star schema is best, guys. When you have enough space in the power pivot, building the star schema is best. So even though it occupies more space, building the star schema will best. On star schema, when you create the visuals, it will give best performance. So there are some cases we'll have less space in the power pivot. I want to save some space. When you want to save some space, rather than star schema, go with snowflake schema. When you go with snowflake schema, it will save the space, guys. The thing is, when you join this, when you load these three tables independently, let's assume they are occupying 1 GB space, or else they are occupying 2 GB space. When you load the three tables, when you join the three tables, when you load it as one table, sorry, first I loaded these three tables independently. When I load the three tables independently, take an example, it is taking some space, guys. Let me explain here. I loaded three tables independently. 1, 2, 3. When I load three tables independently, it is occupying, when I load three tables independently, it is occupying 1 GB space. Take an example. If you go to Power Query, if you combine these three tables into one table, then when you load it, it will occupy more than 1 GB, guys. It will occupy greater than 1 GB. It might be 2 GB or it might be 3 GB. It depends. So understand, guys, when you load it as three tables independently, products table, product subcategory table, product category table, it will occupy only 1 GB space. Take an example. When I combine these three tables into one table, when I load it as one table, when I load it, it will take greater, it will occupy more than 1 GB. So it might be 2 GB or 3 GB also. That means when you try to convert it to star schema, the space is occupying more than snowflake schema. I'll practically show you what happens. So let me explain this same example with EMP table and DEPT table. I'll explain this with EMP table, DEPT table. We are aware of EMP table and DEPT table, right? So let me go to the Power Query first. Click on transform data. Bring the EMP table and DEPT table. Click on Excel. Select EMP, DEPT. Bring them. So when you bring the EMP table and DEPT table, when you load them independently, it will occupy less space, guys. When you load EMP table, DEPT table independently, they will occupy less space. Instead of loading them independently, I can even join them and I can load them as one table. Is it correct or not? You can even join the two tables into one table. You can load at one table. When you join them into two tables, in these two tables into one table, when you load into the Power Pivot, it will occupy more space. When you load these two tables independently, it will occupy less space. Let me give an example. So now, 10th department employees, they are working for accounting and New York location. 20th department employees, they are working for research and Dallas location. And 30th department, they are working for sales department name and Chicago. So here they are storing that in department table. 10th department employees working in accounting and New York. 20th department employees working in research and Dallas. 30th department employees working in sales and Chicago. If there is any 40th department employees, they're working for operations and Boston. Perfect. So now when you store the DNAME and location in a different table, so how many times you have a DNAME accounting? Only once. How many times you have New York? Only once. How many times you have research? Only once. How many times you have Dallas? Only once. Now my requirement is, I don't want to load them as two independent tables. I need to join the two tables. I want to load only one table. So now how can you join the two tables and load it as one table? You need to go to combine queries. And there is a concept called merge queries. Click on merge queries as new. I want to join EMP table with the DEPT table based on a common column called department number column. Based on a common column called department number column, and the join can called left outer join. Press OK, guys. When you press OK, you'll get a new table which contains EMP related data and DEPT related data. I can go and expand what columns I want. I want dname and location column. Press OK. Now I am telling that when you load EMP DEPT to Power Pivot, it will occupy less space. When you load this table, a join table, it will occupy more space. Why? Because look at this here. So when the department name and location is in different table, I have accounting and New York only once, research and Dallas only once, sales and Chicago only once, operations and Boston only once. But when it comes to here, when you join them, those values are repeating. Accounting and New York is showing how many times? 3 times. So 2 times redundant. 2 times redundant. Research and Dallas how many times? 5 times it is showing. 4 times redundant. Sales and Chicago how many times it is showing? 6 times it is showing. So it is also duplicating the data. So when you have the same value again and again, it will occupy more space. But when you have when they are independent tables, these values will not repeat. They will not occupy more space. So if you have 1 lakh employees, in the employee table I have 1 lakh employees. So these values will repeat. There you will get a lot of redundant department names and locations. DNAME will be there many times. Location will be there many times. So that is the reason it will occupy more space. So denormalized means joining all the tables into one table, loading it. Joining all the related dimension table into one table, denormalized. So denormalized means even though when it is duplicate, bringing them to the one table and loading it. That we call it as denormalized. All the dimension tables, related dimension tables, will join them, will bring into the one table where we will have a lot of duplicate data. So in star schema, you will have a lot of duplicate data. Star schema will contains duplicate data. So this is duplicate data, guys. So accounting New York only once. All this comes under duplicate. Research Dallas, duplicate data. Sales and Chicago, duplicate data. So star schema will contains, when you denormalize the tables, when you join the tables. So when you denormalize the tables, denormalize the tables are nothing but joining the tables, guys. When you denormalize the tables, we'll get duplicate data or redundant data. We'll get redundant data or duplicate data. Duplicate data. When you get redundant data or duplicate data, will it occupy more space or not? Yes, obviously, it will occupy more space. It will occupy more space. In the Snowflake schema, we will not denormalize the tables. We'll load them as it is. We'll not join the tables. We will not denormalize. We'll load them as it is. When you load them as it is, you will not have duplicate data. When you don't have duplicate data, it will occupy less space. That is what, guys. I clearly explain why star schema will occupy more space. We will denormalize the tables. That means we will join the tables and we will load as one table. Related dimension table we will load as one table. When you do that, you will get a lot of redundant data or duplicate data. That will occupy more space. But in the Snowflake schema, we will not denormalize the tables. When you are not denormalizing the tables, so you will not find duplicate data or redundant data. It will occupy less space, guys. This is about star schema. When client is asking, so what is star schema? If every dimension table is directly linking with the fact table star schema, what is Snowflake schema? If minimum one dimension table minimum one dimension table. If it is not directly linking with the fact table, if it is linking through another dimension table, it is snowflake schema. Snowflake schema. Which schema will give better performance? Star schema will give better performance. In your project, which schema you build? Best answer is star schema. Go and give star schema. So when you tell that star schema is giving the better performance, so when we need to go and build, I written two more questions. Where is them? So in which cases you need to go with star schema? So if you want good performance, in which cases you need to go and build star schema? If you want good performance, we need to go and build star schema. In which cases you need to go and build snowflake schema? In which cases you need to go and build snowflake schema? When you want to save some space in the Power Pivot, you need to go and build snowflake schema. If you want to save the space in the Power Pivot, you need to go and build snowflake schema. And they'll ask you, in your project, how many dimension tables and fact tables are there? What's your answer? So in your project, how many dimension tables or fact tables are there? The answer is, you can give any answer, guys. So might be, I can tell like 12 dimension tables and one fact table. One fact table. 12 dimension tables and one fact table. Correct. So it is not static count. So project to project it vary. So you are telling that 12 dimension tables are there, one fact table is there. So even you can tell that 15 dimension tables are there, one fact table is there. Or else 8 dimension tables are there, one fact table is there. Any answer is correct, guys. Any answer is correct. But roughly they'll ask you, so how prompt you are, so how much big model you handled. So to understand that, they'll ask you, guys, just go and answer, I have 12 dimension tables and one fact table in my model. The schema which I build, or the model which I build, contains 12 dimension tables and one fact tables. Fine, guys. These are all about data warehousing concepts, guys. So this is more than enough to answer any sort of question in the interview. Any sort of question in the interview. So whatever the data warehousing concepts I discussed in the last class and today's class, those are more than enough to answer any sort of question related to data warehousing concepts. Yes? Anybody have any questions on this?
Can I have 2 fact tables?
Yes. Yes. A schema can even have, see, so that will not become star schema. When you have one more fact table, that schema will be converted to some other schema. What is the third schema I said? Galaxy schema. Galaxy schema. In the Galaxy schema, what you will have is, so I discussed only 2 schemas right here. There is one more schema called what? Galaxy schema. What is Galaxy? So collection of stars in the sky, we call it as galaxy. So here, name itself, it is telling Galaxy schema. Galaxy schema means multiple stars. If you look at this here, you have one fact table called inventory fact table. You have one fact table called sales fact table. 2 fact tables are there in the schema. And that fact tables are joining with the common dimension tables. So take an example. I have a car manufacturing company. I have a car manufacturing company. And I will manufacture the cars and I will sell the cars. I have a car manufacturing company. I'll sell the cars and I'll manufacture the cars. Whatever the amount we are spending for manufacturing the car, I'll store it here. Whatever the amount I am spending for manufacturing the car, I'll store it here. Whatever the amount I received when I sell that car, I'll store it here. So there will be some employees. So it is my own company, ABC company. There are some employees who are working for manufacturing the cars. There are some employees who are working for selling that cars. The products which I manufacture, the same products I will sell. So for so and so duration, whatever the cars I am manufacturing, for so and so duration, I will sell the cars. So in a schema, if you have multiple dimension tables, multiple fact tables linked with common dimension tables, few common dimension tables will be there. Few independent dimension tables will be there, which are related to only one fact table. Now, when you see some schema like this, it is not a star schema, guys. It's a galaxy schema or fact constellation schema. So another name for galaxy schema is fact constellation schema. It's just a name. It's just a name. So here, if you look at here, this is one star. This is one star. So when you look at here, this is another star. So I said that collection of stars, we call it as that. Looking like this is one star. Looking like this is one star. And this is another star, right? Another star. Collection of stars, we call it as what? Galaxy. When I have multiple fact tables surrounded by common dimension tables, so we call that kind of schemas as galaxy schemas. This is not a star schema. When you consider only this, there is no doubt it is star schema. When you consider only this 6 tables, no doubt it is a star schema. When you consider only these 6 tables or 7 tables, it is a star schema, no doubt in it. When you consider all together, it is not a star schema, it's a galaxy schema. So in galaxy schema, the schema is viewed as collection of stars. So how that schema will looks like? What is happening? The schema will looks like collection of stars. The schema is viewed as collection of stars. Hence we called it as galaxy schema or fact constellation schema. In galaxy schema, a single dimension table is shared with multiple fact tables. Look at this. In galaxy schema, dimension table is shared with multiple fact tables. Dimension table is shared with multiple fact tables. Dimension table is shared with multiple fact tables. If you find any schema like this, we call it as galaxy schema. It is not a star schema. Yes, any questions? Very rarely we'll build this kind of complex schemas. Very rarely, guys. Anybody have any questions, guys? No questions? Fine. Now, we want to understand. There are one more important questions. See, if you want to check your model space, so when you load the tables, how much size it is occupying. If I want to check, save the data set, save the report, publish it to Power BI service. I want to check all these tables, how much space it is occupying. You can publish the report to Power BI service. In the Power BI service, you can check that data set size. You can go to app.powerbi.com, log in here. Once you publish the data set to Power BI service, and you can see it. So when you publish the data set to here, you can see it. If you want to see that complete data set side, you can see it here. When you publish the data set here, where you can see the data set sizes, you can go to this 3-dot settings. There is an option called manage group storage. When I go to manage group storage, I can see this data set size is taking 2 MB. This data set is 1 MB. Like this, you can see it. So if you want to see individual size, there is one external tool called DAX Studio. Might be in the DAX Studio, it will show what each table is occupying, how much space it is occupying. We might see in the DAX Studio. So somewhere in the advanced, click on view metrics. So here you might check the table size. You are seeing table size here. So dim customer is occupying how much space. Fact internet sales is occupying how much space. So you might check the size of the table with an external tool called DAX Studio. If you install DAX Studio, you will get that external tool here. When you open it, so DAX Studio will open. So in their advanced, you have an option called view metrics. When you click on view metrics, it will tell you each table is occupying how much space here using the external tool. So what is that question? I don't understand. Is there any possibility to have two fact columns is connected with one dimension column? What is that? So next thing we need to understand is, so let me go to manage relationships. So we need to understand about this window, guys. There is active and inactive. So we know when to go with new, when to go with auto detect, when to go with delete, when to go with delete. We know about these three. And there is edit. If you want to make any changes to the existing relationships, I can go and click on edit. I can make the changes. So by mistake, between fact internet sales and dim customer, I selected wrong dimension column. Take an example. So when you take wrong column in the relationship, you want to edit this relationship. When you want to make any changes to the relationship, I can go and click on edit. Click on edit. When I click on edit, I can go and change the relationship here. I can go and change whatever you want. Whenever you need to modify any relationship, so you just want to click on edit, guys. So another way to make changes to the relationship is, between these two, I need to make the changes. Between these two tables, I need to make some changes to this relationship. One way to make the changes to this relationship between dim customer and fact internet sales is, go to manage relationship, go and select that relationship here and click on edit. When I click on edit, a edit relationship window will open where you can make the changes to this relationship. Another way to get that edit relationship window is, just select the relationship, double click on it. When you double click on it, it will open the same edit relationship window where you can make the changes, where you can go and make the changes. So we know edit relationship is just to make any changes to the existing relationship. When you select wrong cardinality, or when you select wrong or common columns, or if you make any changes with your relationship, go and click on edit case. The next one we have is, so this checkbox, active and inactive. When you need to check this, when you need to uncheck this, important question, guys. Important question. In interviews, they'll ask one question like this. In Power Pivot, between the two tables, how many active relationships you can have? In Power Pivot, so between two tables, how many active relationships you have? Is the question. How many active relationships you will have? Is the question. So what is active relationship and what is inactive relationship? What is active relationship and inactive relationship? There are two types of relationships. So in the model, when you establish the relationship, you will get sometimes dotted line. When you see dotted line, this is an inactive relationship. What is inactive relationship? When you see bold line, it is active relationship. What is active relationship and inactive relationship? What is active relationship and inactive relationship? So we will understand this in tomorrow's class, guys. So in Power Pivot, between the tables, two tables, how many active relationships you'll have? How many inactive relationships you'll have? So we'll discuss them in tomorrow's class. To discuss this, it will take time, around 20 to 25 minutes. I don't have that much time. I'll discuss in tomorrow's class, guys. Before we stop for today, anybody have any questions? You can go.
This conference is no longer being recorded.
Hello, sir. Sir, in
Yes.
Power Query, while filtering the data, sir, have a more number of tables in the like more data. 7 lakh columns are there in that, sir. Actually, only 1,000 will be loaded here.
7 lakh columns or 7 lakh rows?
Oh, sorry, 7 lakh rows. Okay, only 1,000 loaded, sir. Okay, because I do not know what data exactly it is there. Suppose, for example, cities named Chennai, Bangalore, many city names will be there. Some city will be there in last. more whether is there are token data? How we will do that, sir?
Have you done with Power Query?
Yes, sir.
So then why you are asking this question again?
Actually, I have tried to one click on this one show more. In that it is showing only 1,000 is limit is which is showing there, sir. Actually, for me.
1,000. See, will you apply the filter condition by scrolling and seeing more than 1,000 values? What is your requirement? Do you have any requirement in your project for this? Others, please be on mute. Others, please be on mute. Do you have any requirement? So, do you think that you will see more than 1,000 values here? When I click on load more, you are telling that it will show only 1,000 values. Do you think that you will go and apply the filter condition by seeing more than 1,000 values? Will you read all 1,000 values there?
How I come now? When the city is there in the data, how I come to know, sir?
Just go to the text filters and write your city name. That's it. What is the need?
So that I tried actually. What happened? In some cases, the spelling they are not storing properly, sir. Actually.
So you at least you need to know what data is there in your database. What spelling is there in the database? You need to know. Go to the database and check it.
Okay.
Go to the database and check it how the data is.
Sir, that is fine. If it is there in the Excel sheet something, we can check it. If it is in the SQL server, how we will check that one, sir?
Write a query and check it. How the data is.
Okay.
You need to write SQL query and you need to check it. Here, going and checking the value in more than 1,000 rows is not a recommended thing. When I even click on road more, can you go and check the name here? So write it here and check the name. If you're not exactly matching it, go with contains first and check it how the name is and then write equal to condition then.
Okay. Fine, sir. Fine. Okay, sir.
So I'll discuss many-to-many cardinality. I'll discuss many-to-many cardinality in tomorrow's class. Wait, we're not yet done. We'll discuss. Yes.
Hello, sir. In Galaxy schema, we can put one dimension table without connecting to fact table.
Leave it, no problem.
No
It's
problem,
not mandatory that every table need to be collected. You can.
Okay, sir. Thanks.
Right. I'll save it as types of schemas, guys. Today we discussed about types of schemas. Desktop, click on save. Click on publish. I'll publish it to 7 a.m. May 2021 Power BI files. Click on select. So we'll discuss. I will even discuss that many-to-many cardinality. We will discuss. There are 2 more hours. We need to discuss about Power Pivot. We are not yet done. We'll discuss few more things here. So active and inactive we need to discuss. In the cardinality, there is one cardinality with many-to-many, when to go with many-to-many, and there is cross-filter direction, single and both. And what is this active, inactive? Assume referential integrity, apply security filter in both directions. We need to discuss all this. So we'll discuss them in next classes. So this is also important. So a lot of questions you will get it from data modeling, guys. So whatever the data modeling classes I'm going to cover, those are more than enough to answer any sort of question. Fine, guys. Thank you. I'll stop here. I'll continue from here in tomorrow's class. See you tomorrow, guys.